Assalamu alaikum and welcome to lecture number 13. We are going to discuss inverse trigonometric functions. In this lecture, by the end of this lecture, you will be able to apply inverse trigonometric functions confidently in Python coding and solving many problems involving the inverse trigonometric function. In our previous lecture, we explored trigonometric functions in Python, where we learned how to explore math library, how to convert degrees to radians, how to compute values like sine, cosine, and tangent. Today, we are talking the next important step in this journey by introducing inverse trigonometric functions, a powerful concept used to find angles when the trigonometric value is already known. This topic is extremely important for the students of engineering, mathematics, data science, programming, and many other areas. In this lecture, we learn how to find inverse trigonometric functions using Python, why results are in radians, and how to convert them into degrees. So let me paste this material here and let's start the coding. Okay, so we will first import the math library. So import math. Okay. Next, we are going to use these functions. So to use the functions, we will use the dot notation. So for example, we are given the values. For example, we have value 1 equals to, for example, 0.5. Similarly, value 2. Let me correct the spelling. Value. Okay. So 2 and value 1. So value 2 is equals to 0.866. And then we have third value, which is equal to 0.577. Okay, so next we are going to use the inverse functions. So from the previous lecture, you understand we can use the inverse trigonometric function from the math library. So let's say sine inverse is equal to math.asin. You understand asin is for inverse sine. So we have already imported the library. We just need to put the value whose inverse is to be found. So let's say we have value 1. Okay, so let me copy paste. Okay, so say the second one is cos, so we'll have a cos, and instead of sorry, I just made first one is, for example, sine. Then the second one is, for example, cos. So I'll write a cos and I have value 2. Similarly, this third one is, for example, tangent. So a tangent means inverse of tangent, and this is the third value. So if I run the code, it's running. So that means there's no error here. So now let's print each of the values. Sorry, I forgot to rename them. So inverse of first one is inverse of sine. The second one is inverse of cos, and the third one is, for example, inverse of tangent. Okay, so I just print these values. So I write print and sine inverse. Okay, and then I run it for, so it gives 0.52. You understand these values are, this is for 0.5 sine inverse should be 30 degrees, 0.8 866 should be, the cos inverse should be 30 degree, and similar tangent should also be 30 degrees. So can anyone tell me why we get 0.52? Okay, I give you some time, you just think why you get this one. Meanwhile, I keep coding. So this is for cos, and this one is for, sorry, cos, and this one is for tangent. So I get these, and let me run this code again. So you see, all of them are giving me 0.52, 0.52, and 0.52. So hopefully you understand, because math library uses radians. So this inverse is basically in radians. So 0.52 is basically in radian. Now we can also use the built-in function, the function present in the math library, to convert this into um, degrees, right? So how we can convert them into degrees? So we use the degrees function. Okay, so if I just write, okay, let me just print these, copy these, Control C, and then I write the Control V. So if I write here math dot degrees, so it will convert this radian into degrees. Okay, so again, I write here math dot degrees. Okay, and again here closing the bracket. So again, math dot degrees, and it will convert it into degrees. So let me run it. Yes, so you see oh, there is a problem. And what is the problem? Line 10 print this was. So let me see what is the problem. Module math has no. Okay, so mistakenly I have made, yes, sorry, this is spelling mistake. So that means it should be dig and rees. So it should be fine now. Okay. So you see, this is roughly the first three values, they are in radians, right? So whereas the last three values, they are in degrees. So roughly this one is also around 30. So you see how easy it is to find the inverse functions, trigonometric inverse functions in the Python. So you see that all we have to do is to import the math library, and to to use function inside this library, we use the dot notation. So if I write math.asin, so that means I am utilizing the math library. In math library, I am using the inverse sine function. So we use the dot notations. This is very much clear to you, that we have already discussed in the previous lecture. Now to summarize, we saw how normal trigonometric functions and their inverses are connected, and how we can one can use to verify each other. So you can also use the same, I mean, you can take the angle as input, then you find its sine, and you can verify it by finding its inverse. So you understand, again, the important thing is the radians, and you understand that math library deals in radians. So that means whatever angle is, you have to first convert it into uh, radians. If you have the angle in the degrees, degrees must be converted into radians. Okay, make sure you practice these concepts, especially using Python, because they form the basis for many advanced topics in maths and engineering, as we have discussed already. So we also reinforce the important idea that math library in Python works in radians, and we must be careful while carefully convert between radians and degrees depending on the problem. Now your homework is, using Python, evaluate the following inverse trigonometric functions. So sine inverse of 1, cos inverse of 1, and tangent inverse of 1. Now the tasks are compute the values of the given inverse trigonometric function in radians using Python, and then convert the obtained values from radians to degrees, and display both the radians and degree values clearly as we have done in this lecture. So that's all from my side. I'll upload this code on the GitHub. See you in the next lecture. Until then, goodbye.